Yep, I cooked so much that I lost internet. Sorry, when it starts raining too much, my internet died. That's why I pay extra for Telstra. Yep, yep, good stuff. I'll just wait for more people to come back. The rain stopped, so my internet is back, so this is good news. Just wait for a few more people to return to the lecture so that I don't lose everyone again. Maybe people aren't coming back, who knows? Maybe they've decided they're all cooked, this is cooked, no one wants to delete from a linked list. Ugh. Oh, it's magic to my ears. Linked lists are coming together. That's what I love to see. We're so back. Yeah. Okay. How are we feeling? We're about halfway through the people coming back. Ugh. Start or wait a little bit longer? 2 more minutes? No, I'm paranoid it's died again. No one's saying anything in the chat. Keep the chat going. Keep the chat going. Yes, I have a really old house and I decided to lecture from my house today because someone in the office next to me told me I was very loud when I was lecturing last week. So, and my old house, when it's raining heavily, loses internet. All right, perfect. Let's start. Okay, so let's do it. We've got a function to delete every node in my linked list, which means that we want to free the memory of all the nodes. What do we think is going to be the input and the output of this function if we were to be doing something like that, which is just so exciting. It was funny that we died on this particular function. I literally deleted everything. What do we reckon? Ah, someone thinks the uni has a soundproof room. You would think that, wouldn't you? It got converted to a lab. Yes, the input is the head of the list. There is nothing else that it could be because I need to be able to go through the list and delete everything. And then the output is nothing because I've deleted absolutely everything. So there's nothing left there. So it's a void function. Okay, so my definition is going to be void delete all nodes, and I'm going to give it a struct node head. Excellent. Okay, no, I've done it again. Look at this. Get too excited. Okay, so we've defined it in our .h function. Now let's go to our .c function and let's actually implement this function. Okay, fantastic. So the first thing I'm going to do is I'm going to struct node current is equal to head, which is also going to be like living in your nightmares together with current is equal to current next. So it's going to be, it's just all happening, okay? So now someone before the internet died and we all had to switch streams and it was all a huge disappointment because you missed like, I don't know, 7 minutes of this lecture, which is horrifying. So someone said we need to have a loop. I agree. Okay, fantastic. Now we need to have something, a condition inside that loop, and then something's going to happen here, and we're going to need to do something if the condition is true. Okay, so we've got a few options right now. Either we're going to go until current is not equal to null, which means that when we leave the loop, we've gone through the whole list. So if we go current is not equal to null, that means when we come out of the loop, current is equal to null, and we have traversed every single node in the list. Okay, so what do you think? Should we be going through the whole list, or should we be stopping at the last element of the list? What do you reckon? What does it feel like? So we want to delete every single element in the list. So what do you reckon we should do? And remember, it's fine to get it wrong because we can just fix it. When you see the code running, you'll see that you've made this mistake. Yeah, right. Let's just go till current is not equal to null. And if we don't like it, then we can fix it. Okay, excellent. So we've got this, we're traveling through the loops, the nodes, not the loops. Definitely we're not traveling through the loops. Now we want to be doing something, and that something involves doing some serious freeing. Okay, so at some point we're going to free some nodes, and we're going to do the next thing. Now, what do you think I need to be doing? So I need to be able to, if we are to look at a diagram, okay, which will help us a lot to even write this code. Okay, so if we look at the diagram, then what we need to be doing is we need to be, now my pen's died, my God, what is happening here? Okay, so I've got this lovely situation here where I've got a node here and it's 11, and this is A, and it's going to this node, and this one is XXX, and the head is currently XXX. So what I want to be doing is I want to go through the list. I want to delete this one, so I want the head to be on the next one. Then I want to delete this one, so I want the head to be next. So should I be changing the head to be the next node first, or should I be freeing something first? What do we reckon? What are we feeling? So should I move my node along first, or should I delete the node first? Yeah, so I need to change my head first, because if I don't change the head first and just delete it, I will not know what comes next after it, right? So the first thing I need to do is I need to move my head along. Okay. Now, when I said to you, okay, if I'm moving my head along, what it means now is I've lost the head, except that the head is currently stored in a pointer called current. So what do you think am I going to free? Am I going to free the head, or am I going to free current? So up above, we freed the current. So I would imagine we would free the current again. Okay. And then now we've moved on. We've moved by one. So what do we need to do? We need to do one more thing in this while loop that's right. So we need to move the current, because right now we freed the current. The current was the head. So now we need to make the current equal to the next head. Okay. Because that's going to be the next thing that we delete. And then we're rolling. Yeah. We are rolling. Okay, so if we are to run through this code quickly with a diagram, so you can see what actually happens, and then we can actually run it to see that it's doing what we want it to do. So let's run through it. So the first thing we have in here, we delete all node and we give it the head of the list. The head is XXX, which is this node over here. So now I've got the current and it's equal to head. So over here, I've got my new variable pointer and it's pointing to that first node at the address XXX. Great. So whilst current is not equal to null, is current equal to null? No, it's not. So what I'm going to do is I'm going to do the next line of code. I'm going to go over here and I'm going to say head next. So I want to go into the head, dereference the next pointer and see what's there. There's AAA in there. So I'm going, and then I'm going to assign it to the head. So the head is now going to be AAA. Then I'm going to free the current. And the current was XXX, so the current was over here as well. And I'm going to free it. So I've moved it along. And now I have taken the head of the list and I've assigned it to current. So at the head I had AAA, and so my current now gets AAA as well. I'm going to go through the loop again and I'm going to check is current equals to null. Okay, so is current equals to null? No, it's not. Current has an address in it. Fantastic. So I'm going to enter into the loop. And I'm going to do the right side here first. So I'm going to dereference what's sitting inside the head next. So AAA is the address I'm going to, and I'm going to look at what's next in it. And in next is the address of the next node. So it's BBB. And I'm going to assign that address to the head. So now instead of AAA, it's going to be BBB. Great. The next thing I'm going to do is I'm going to free the current. The current right now is at address AAA, which means that I'm going to free that address. And then the next thing I'm going to do is I'm going to move my current along as well. So my current is equal to the head. The head is BBB, which means that my current is now BBB as well. I'm going to check again, is current equals to null? No, it's not. It still has an address in it. So I'm going to go into this loop. I'm going to dereference whatever is sitting inside head and then whatever's in next. I'm going to go into BBB, see what's next. It's null. And I'm going to assign it to the head. So now that's going to be equal to null. The next thing I'm going to do is I'm going to free the current. The current is BBB. So I'm going to free this node. I'm going to get rid of the memory associated with it. And then I'm going to say, okay, let's move the current as well. And it's equal to head. So the current is now equal to null. Great. And I'm going to check the loop again. Is current equal to null? Yes, it is. And that means that I exit out and I've deleted all the nodes. And if I look on my diagram, that is true. I have deleted all the nodes. So you can see that if you would have had current next is not equal to null, then you would have stopped one short. Okay, so we can see that in a second. So let's have a look if this works. So the diagram works if we run through the code as though we are the computer. So let's see it actually doing something. So now here, instead of doing that, I'm going to delete all nodes and I'm going to give it the head of the list. Okay, let's compile it and let's run it. And I am going to get a runtime error. Why have I got a runtime error? Who knows why this runtime error happened? We have a look here, the runtime error. What do we reckon? So it happened inside, we can see it happened inside the function print list. Okay. And if we go to our function print list and have a look at it, right over here, so what are people saying? Well, I can't have head is equal to delete all nodes because delete all nodes does not return anything, right? It's a void function. Yeah, so print list doesn't really consider what happens with an empty list right now. Yeah. And it's doing a whole bunch of stuff. So we will return to it. Okay. So hold that thought on this error. Okay. And someone's saying, okay, it could be a good idea to get the delete all function to return null when you finish and set that as the new head. We could do that. So hold that thought. We will come back to it, okay? I want you to just remember this, okay? Because these kinds of errors happen all the time, and we will come back to fix it. Okay, but to demonstrate why it's doing that, I want to also do some searching and deleting of nodes, right? Because what that will do is it will show us exactly why this error is happening, okay? Or how do we feel? Do we need a break, or should we just push on and count the internet breakage as the break? Thoughts, thoughts, thoughts. How do we feel? Push on, push on. Okay, push on. Let's keep going. Okay, so what I want to do now is I want to search for a particular value, and then what I want to do is I want to delete that value, because I think once we do that, that might help us to understand why this print list situation is occurring. Yeah? Okay, let's do it. If we now want to I actually do want to show you the only ways forward. I love that. We should check for a memory leak as well. Should we do it now? I'm going to just quickly show you how to check for memory leaks, okay? Maybe we should. Okay, so right now, all of this, when we've done delete all, and it will become more clear, but when we've deleted all nodes, there is nothing there, right? There is no nodes left. There's no memory left. All the memory has been returned. So what happens is when I try and print a list with the head, there is nothing there to print, and I'm going to obviously have an error. Okay, so what I would like to do is I would like to also, if you remember, we've said something, and this was a few weeks ago, so you might not remember, but there was this amazing situation where you will have a memory leak. Okay, and the memory leak basically occurs if you've mallocked some memory and then you were very greedy with it and you did not return that memory back. So remember that when you call malloc, you are in charge of that memory. That means that you need to be able to return that memory to the heap to be reused and to have it back, right, whilst the program is running. So otherwise you'll have these spots of memory that are taken up, not freed, and they cause these memory leaks. You're going to run out of memory at some stage. Not in 1511, we don't do anything so complex that you'll run out of memory, but overall, anytime you malloc a piece of memory, you need to free that piece of memory. So we have something for you so that you don't have to use these intense tools to check for memory leaks that allow. Okay. So we're going to leak check. Who has seen on the forums and stuff what you do to leak check? No, not again. No. The stream is back. Oh, it held. It held. I was just trying to leak check. Okay, so if we compile with leak check, if there is, can you hear me? Can you see me? Can you, it's not raining, I shouldn't be, where are we at? But can you hear what I'm saying? I'm going to see what Bree's saying. Audio's out of sync. Fantastic. We're having such a good time today. Thank you, Bree. Stream is okay. All right. So I mean, you know, weather dependent internet. You just could not make this up if you tried. Okay, so compile it with this leak check command, and what that does is it checks that every single piece of memory that you have mallocked, you have also freed. So that will tell you if something has happened and you have forgotten to free something. When you're going to be doing your assignment 2, we're going to be checking that you have left no memory. So that you've deleted all the memory that you've mallocked, okay? And that's part of the testing, and that's part of how we make sure that you get, you know, good programming practices to start with. So once you start deleting in assignment 2, then start using the leak check when you're compiling, because that's going to make a huge difference. And you know what? I mean, it's lots of security vulnerabilities happen because of this issue when we don't free memory that we have mallocked. It's you know, a common thing to happen, but it causes some serious issues. So we want to get into good habits early. Make sure you malloc and free that whatever you've mallocked. Whatever you've taken, give it back. Be nice. Okay, so the next thing I want to do for a second, okay, I want to search for a particular node and delete that node. Okay, and oh, thank you. Okay, so just refresh the stream, and then I'm all in sync again. Just like when you're streaming shows and well, probably no one else has that problem except for me and my internet. Even though, yeah. Okay, good chat. Let's go to the header file, and now I want a function that will search for something and then delete something, right? Yeah. That's right. Okay, so I want to search for function, to search for a value like we had in the slides, and then delete the node with that value. Yep. So free the memory. Okay, excellent. So what do we think is going to be the input, and what do we think is going to be the output? What do we reckon? I should have shown you what it does when it does complain. I will go back to it to show you after the break. Okay, so search, and we're going to search and then delete something. What do we reckon we need to give this function, and what will we get out of this function? And this time I'm going to use that previous. Yep. Yep, so I want to give it the head and the value that I am looking for, which makes sense. That's the value that I want to delete. And the output is going to be the head, just in case I'm also deleting something at the head of the list. The head might change, whatever happens. So my definition is going to be struct node, delete value, and we're going to give it a struct node head, and we're going to give it an int value. No, I'm in the header file. Okay, excellent. So now let's go to our .c, and that didn't save. Let's save that, okay? And let's now work through this function. Okay, so we know at some point we're going to be returning head, so I'm just going to pop that in as though it's like a little template. So if you remember what we talked about, when I'm deleting a node, I want to stop not at the node that I want to delete, because that I don't know then what came previously to that node, but I want to stand at the previous node so that I can access whatever happens after it, and I can connect up the node that came prior to the node that I want to delete to the one that happens after the node that I want to delete. Okay, fantastic, good. So let's go through it. So I want to now keep track of a previous node and a current node. So I want to have two variables that I'm going to work with. I'm going to have a struct node previous. Okay, we'll talk about what you should set it to. And we're going to have a struct node current, and it's going to be equal to the head of the list. So where do you think, oh, this is now a royal mess over here. If my current is standing at the head of the list, where do you think my previous is standing when the current is at the head of the list? What do you reckon it would be? What do we reckon? And whilst you're thinking about that, I'm going to redraw this list so we can play with it. Yeah, well done. Lots of people are saying no because I'm standing before the head, so I'm standing at nothing. That's right. Okay. Okay, great. So that means the head of the list is going to be equal to the beginning. So I'm over here. And my current is going to be equal to the head of the list. So it's equal to this. And my previous pointer is sitting somewhere over here. That is the ugliest arrow I've ever drawn. So my previous is currently equal to null because my previous is sitting over here. So I'm sitting at null. So previous node is over here and it's at null. It's not, and nothing is happening. Okay, great. So I am ready to go. Over here, I'm keeping track of 2 sets of pointers. Excellent. So what should I do next? What do you reckon? I need to be able to search for a particular value, and then I need to be able to delete when that value has occurred. Okay, excellent. So I need to have a loop that checks whether I have found the value that I want to delete, and also that I have not gone past the end of the list, okay? Because that value might not be in my list. I might be searching for a value that doesn't exist. So if we're to quickly diagram before the code, just to see what we want to achieve, okay? So let's say I want to delete the number 42. Let's say I want to delete a node with 42. That means that I want to be, if I go to the number 42 and I find what is happening, this is a node. If I'm standing, if this is my current node, and this is my previous node, that means I want to have the previous point to the current next. So the previous needs to point to this current next, and then I can delete my current node, okay? So I'm searching whether my value is going to be equal to the node that I want to delete, and I also want to search whether or not I have traversed the list. Now, what do you think I need to go again? Will I need to stop at this node, or will I go all the way to the end of the list? How will I do my loop? What do you reckon I need to do? So keep in mind, it can be anywhere, my node that I want to delete. Yeah, that's right. It's going to be, yep, we're going to connect. So my previous next is going to be equal to current next, because, but that's going to be at the end. I agree that that's definitely going to happen. Yeah, previous next is going to be current next. That's going to link up. That's going to give me this link over here. The link from here to here. I'm going to go into previous next, and then I'm going to give it whatever this address is. I want that to be pointing to that one now. So I want it to be BBB, and that address is stored in current next. So that absolutely, that's going to be how I create that connection. But first I will need to be able to move through the list. So if I move through the list, I'm going to have while, and I'm going to have two things here. I'm going to be checking whether or not the value is equal to, and I'm also going to be checking whether or not I have gone through the list. Now, because I want to be able to move through the whole list, right? I need to check every single element of the list. If I go to current next is not equal to null, what's going to happen is when I go to here, when I'm standing at this node, my current next is equal to null. So when I exit out of the loop, right, I'm going to be standing at the last node. And depending how I do my programming, what it means is that I might miss actually deleting that node if I will not check for it. So you have to be a little bit careful with that. And again, we're going to run through it and we're going to see what happens. So I'm going to start by checking that I'm going to go through the whole list. So current is not equal to null. And I'm going to check that my current data is not equal to value. So that's checking for two things. That's checking that I haven't gone past the end of the list. So I haven't gone past the end of the list. And also it's checking that I haven't found a node that I want to delete. So this means that when I exit out of this loop, okay, when I exit out of here, either I have gone past the end of the list or my current data is the value that I want to delete. So that means I want to keep moving myself along, okay? Because when I come out of the loop, that's going to give me something that I want, which is I'm standing at the node that I want to delete. So we already know how to move our current along. Current is equal to current next. But I also have to pull that previous along because I now also have a previous pointer that is working with me. So I want to be able to pull both up by one. So what do you think I will do and where will I put it? Will I move the previous before the current, or will I? So if you think my previous is over here, my current is over here. I now want the previous to be whatever the current was, and I want my current one to be whatever's the next one. And I kind of just said it out loud what I want to actually happen. But should my previous be the first thing to change, or should my current be the first thing to change? Yeah. So the previous should be the first thing to change, because if I move my previous, yeah, before moving the current along. Okay. So this means that when I exit out of here, either I've gone past the end of it, or what happened is I'm equal to the data that I want to delete. Okay, excellent. So we're going to have some problems if we have moved past the end of the list, yeah? So if two situations could be true, either current is equal to null, and that means you've gone past the end of the list, you should not be deleting anything, okay? Or current is not equal to null and you're partying. So we're going to check here that this is not the reason that we have exited that loop, okay? And if it's not the reason, it means that I am still in the list. There's still some things in this list, and that means I can kind of do my delete, yeah? So we have said if current is not equal to null, and keep in mind the way I write code, there's going to be some Easter eggs in here. I'm going to make some mistakes so we can see what has gone wrong. And these are common mistakes that you will make as well when you do your assignment. So just bear with it. Okay, so we have said before that we want to say previous next is equal to current next. And this is all in the wrong order right now. And we want to free something as well. Yeah, what do we free? My dog thinks we could free any node. What do we reckon? My my God, I hope the stream hasn't died again. No one's saying anything. Yeah, we want to free the current. Yeah, fantastic. Okay. Even if you're brute forcing this, whatever, still working. Okay, so we have some code that may or may not work. And we're going to see whether it may or may not is working. So if current is not equal to null, then that means we have decided that this is the case. The current data is equal to value. And I'm going to do some deleting. I'm going to make the previous next is equal to the current next. And then I'm going to delete that node in the middle. Okay, great. I think what is left to do for us is we need to run this code and see what it does. Okay, so I'm going to go to main. And I'm going to not call this function, otherwise we'll have nothing to delete. And I'm going to call this function delete value, and I'm going to give it the head and a value to delete. So remember that at this point, our list looks something like this. We have 11, we have 42, and we have 13. And then we have null. Okay, so we want to delete. Which value should we delete first? Going to be some issues. Let's just delete something in the middle first, okay? Always try the good case first. And again, remember that I'm going to give away what might happen. We're going to do head is equal to that, and then we're going to print the list. Okay, let's give it a whirl. Someone can see ahead. It will indeed have some issues. It will indeed have some issues. But first we're going to do our normal thing. And our leak check has told us, actually, you've also stuffed something up. Free not called for memory allocated with malloc in function create node. So it means the free has failed. We'll look at that in a second. But you can see the output of that leak check. But what it has done is it has deleted the node that we want to delete, right? We've got 11 and 13. So things are okay. Okay. I guess we can kind of count that as a win. So something in the middle is deleting okay. Now, till I'm blue in the face, broken record, I'm going to say, what is the next thing you're going to try? And a few people in the chat have said, you got to try deleting the head, right? So always empty list, in the middle, the head, the tail, and what happens if that value does not exist in the list. Let's do the head now, okay? Let's do the head and let's see what happens. So if we compile it now, everything's okay. Always that false sense of security because it's lots of runtime errors. And of course, we get an error, okay? And we get a runtime error because we've accessed a null pointer. So when we tried to delete the head of the list, what happens is, if you remember, our struct node previous is equal to null. And when we try and do this situation over here, this previous next is equal to current next, what happens is the previous next is accessing a null pointer because my previous has not moved. I'm at the head of the list, which means that my previous is still null. So I've dereferenced a null pointer. Okay, so that's a case that I haven't taken care of yet, and I really need to. Okay, so we need to check here. Okay, we've checked that current is not equal to null, which means that we haven't traveled past the end of the list. But now we also need to check that our previous is not equal to null, which means that we're still at the head of the list. So if I check that my previous is equal to null, it means that I am at the head of the list and I'm going to do something else. If I'm deleting the head of the list, what have we done so far? I'm going to move my head one off. So if I move my head one off, I'm going to just head next. Okay. Otherwise, I'm all good to go with whatever it is I was doing here. So otherwise I'm going to do this and I'm going to free the current. Yep. How does that sound? What do you think about this? Should we try it? Let's give it a whirl. Okay, so let's compile it again. So we've hypothetically now taken care of that case if we're deleting something at the front. Okay, so we have deleted the head node. Okay, we still got this beautiful situation here, which we will fix in a second. Well, in a few seconds, don't worry about it. But when the head seems to be working. So now let's do the tail. Okay, let's do the tail over here. So let's delete something at the end. And okay, so we've managed to delete the tail. We now have 11 and 42. We've deleted that 13. So things are going okay for us. Okay, so the tail seems to be working. So what is one more thing that I should check? Very good question over there. This function doesn't delete all the values that are the same. It only deletes the first instance of it. That was a very good question. Okay, we'll diagram out the code so that we can explain the if. So what do you reckon we will do? What's one more thing that we would check and test our code with? We could delete something that's not in the list. What if we search for a value that doesn't exist? What do we think of that? That's something that can happen. So let's compile again and let's run it again, and it's all good. Yeah, it's not complaining too much. So that seems to be okay. Okay, so that seems to be working, except for there is a memory leak, which is okay. We will deal with that memory leak as we go. Don't worry, it's just that I need to keep building on what you know first, and then we will take care of the leaks. That really goes for your brain power too. Now, how cooked are we feeling at this point in time? Do we want to do a Kahoot to have a little break? What are we feeling? Kahoot just to have a little break in the action? There's a huge delay. Yeah, let's do it. Yeah, let's have a little break. I think everyone needs a little brain power back. Brain power back. I think I need some brain power back. Let's do it. I can't provide coffee, but I can provide a Kahoot. See, it's funny you say deleting's not as bad as inserting. I think inserting is easier than deleting. Oh, someone has given, yes, you would solve the memory leak with deleting all the nodes. That is correct. So we will talk about that after the Kahoot. Well done. Brain fried. I'm not sure what I've, yeah, sorry. Week 8 vibes. You're going to have a great time in COMP1521. Going to do some fun stuff with pointers. So when we do this Kahoot, we'll run through the code and we'll diagram it out so we can see where that if comes from and stuff, and then we will fix up the memory leak. Oh, Not everyone wants to do a Kahoot. Someone is just... I know, I don't know why. All right, let's go. Let's go. Well, I quite enjoy this free me. That's actually quite funny. Just another 3 weeks to go, then you will be free. As long as you pass the exam, you will be free. Well, you don't actually have to pass the exam, as long as you pass the hurdles and the whole course as a whole. Okay, let's do it. Let's go. I hope everyone gets this right. Almost everyone gets this right. You know, when you malloc some stuff, is when you take some memory on the heap and you use it as you want it. So linked lists are not fixed size data structures. They are things that we are in control of. So we are the ones that take the memory and we take nodes as we need them. Whereas with arrays, we have to specify at compile time basically at the start how much memory allocation it needs. Whereas with a linked list, we create and delete nodes as we need them. So it's not a fixed size data structure. It is all over the shop. You can do whatever you like. Okay, amazing. Oh, salmon, always on the leader table. These are false sense of security questions. Come on, people, come on, yay! Okay, so the reason it's not C is because for a linked list, it has to be, for a linked list, it has to point to the next node, which means that this has to be a struct node next. It has to be exactly the same as whatever the initial definition is of the struct, okay? So a struct node has the data and it has a pointer to the next node in the list, and that's what makes it a linked list. So that's why it is going to be this one over here. Okay. Who's next? Let's go. I've said it like 70 times today, this one. But then my internet also died, so maybe no one remembers that. Sorry, I'll stop talking. I do love to have a good yap. Okay, yeah, memory, malloc, free, you're on the heap. And don't ever judge these questions. Some of them are written when I'm very, very tired in the morning. This one wasn't. And by morning, I mean like 3 to 4 a.m. It's not really the morning, is it? I love that someone loves linked lists. I mean, I love that. Yay, well done. That's very good. Well done. So we want size of 1 int and then we multiply it by 5 because we want 5 ints. Fantastic. Let's see with the, oh, Alan. Come on, you can regain the podium spot. How about this? A function that has 2 lists. Oh, so close. So this is basically the head 1 is 3, 4, 5 list. Head 2 is pointing to this 6, 7, 8 list. So the current 1 is head 1, the current 2 is head 2. So when current 2 next is not equal to null, that's going until the last node in the second list. So then current 2 is equal to current 2 next. What it's doing is it's traversing through the list until it stands at the last node. So it's going to go from 6 to 7 to 8, and it's going to stop here. So when it exits the while loop, it's going to be standing at 8, and then it's saying current 2 next is equal to head 1. So it's going to hook it up to the address of 3, which means your final list is going to be 6, 7, 8, 3, 4, 5, X. Yeah? We've got this. Ooh, who is, oh, a whole bunch of new names except for Alan. Alan's still there. Oh, very good. I've Maleked some memory and I have not freed that memory. That's the issue here. Malek, and it's got no friend. It needs to have a free. Everything else is all good. Okay, so we need to revise pointers. I'm with you. Okay, let's see what happens here. See, Kevin, I said you can't, you got to keep going. I deleted this question. I don't know why it's here. Yay! Okay, so the keywords there is while the program is still running. So while the program is still running, you need to free the memory that you have mallocked, okay? Otherwise, that memory is not released, okay? All right, let's see who's been bumped off. A few people have been bumped off, but not Alan. Alan's still there. Well, and also, I don't want to mispronounce that. Okay, second last question. Just giving your brain a chance to decompress again with this question. Oh, amazing. 2 things correct. Very good. Well done. So you only call free when you're deleting things. You don't need free when you're searching for a node or when you're adding an element to a list. You don't call free then, you call it when you do deletion. And when you finish your program, you want to free up everything so that you have no memory leaks left. Okay, absolutely, just staying in the lead, not going to be bumped off. Last question. Let's see what happens now. Oh, it will have a runtime error. Excellent. Who knows what that runtime error is called and why that runtime error occurs? So the runtime error occurs because you have freed the memory associated with head, and then you try and use it again afterwards. So after you free memory, you're not really allowed to use it anymore. That actually, this use after free error can lead to also security vulnerabilities. So we will talk about that. It's the same, you're only allowed to free memory once. If you try and call free on memory that you've already freed, that also leads to issues. So there you go. All right, let's see who's winning. Alan. Who's number one? Oh, absolutely. That was throughout the whole thing. John, throw some chocolates into the audience. We don't actually have an audience and no one's allowed to use, well, I can't really throw you chocolates. I don't know where you are. It'd be fun if someone could like walk through the library, find the people that are listening to the lecture, and then, okay, now I'm just going crazy. So anyway, well done. A little bit of, like a little bit less cooking, and now a little bit more cooking. Let's not get crazy. We're back. Okay, we're going to run through the code that we just wrote, and then we're going to talk about that memory leak. You have got to be kidding me. Disconnected me again, but luckily not from the stream, just from my connection here. It hates me. It hates me. All right. Amazing. Let's run through the code. So over here, we are saying delete value. I'm going to delete, and I'm going to delete at the head because that's kind of what we took care of. Okay. So head 11, I'm going to delete this node over here, and I'm calling delete value with head and 11. Let's have a look what we have going on for us when we do that. Okay. So we've got some nodes, we're all very excited, and this is the situation that we have with the code. Now my pen's not working. Hang on, I'm back. Okay, so we start out with this situation over here. We start out where previous is equal to null, which we have over here. So it's standing over here, and current is equal to head. So current is equal to head. So that means that what we have is this situation over here. So previous is standing over here right now, and current is standing over here. Okay, great. Now we've got a loop going over here, and the loop is whilst current is not equal to null. So we're checking current, yep, it's not equal to null. There is a node there, so we're all good. And current data is not equal to value. Now remember that we're looking for value 42. So current data, I'm going to go into my current data and I'm going to check this value. This value right now, oh no, we were not looking for 42. Why are you letting me lie like that? We're looking for 11. So in fact, we are going to. Okay, so we are looking for 11. Excellent. And that current data is actually equal to 11. So what happens is that is not true. So we're going to skip out over here and we're going to check a few conditions over here. So the first thing is we're going to check that we haven't gone past the end of the list. We're going to check that current is not equal to null. Current has a node, so it's definitely not equal to null, which means we're going to go into this if statement and we're going to check the next condition. And this is the condition that occurs only when we're deleting at the head. So if previous is equal to null allows us to check that we're deleting at the head, and it means that we don't try and dereference our previous pointer when it is null. So previous is equal to null. It's null over here, and over here I'm standing nowhere. That means that I go into this statement and I say head is equal to head next. So head right now is over here, and head next is AAA. So I'm going to assign a new value here, and head is going to shift along to this node over here. Excellent. And now I'm going to skip out and I'm going to free the current node. So I'm going to, current is still over here, and I'm going to free that, and then I'm going to return the head. Okay, so that works great. I've done deleted at the head, no problem, and then I've returned the head, and the head is sitting over here, so it's not a problem. I've returned something that's 4213, and we saw it working. So now let's try and search for number 42 and see if that works. If we can delete in the middle. So now let's do 42. Okay, we're going to try and delete 42. So again, struct node previous is equal to null. So previous is standing nowhere. It's not pointing to anything right now. And my current node is equal to head. So the current is standing at the first node, and I'm ready to go. So I make my check. First I check current is not equal to null. That is true. There is a node here. So this is okay. And I'm going to check that current data is not equal to value. I'm going to go into this current data. It is 11, and 11 is not equal to 42. So this is true, which means that I go into my loop and I do some things. So the first thing I do is I take the current and I place that address in the previous. So I take the current, which is XXX, and I place the address in the previous. So this now becomes over here, which means my previous has now moved to this node over here. It's no longer sitting out nowhere. And the next thing I'm going to do is I'm going to move my current along. So I say current is equal to current next. Current is still at this head node. So the next node is AAA. So I'm going to move my current along to current, whatever's sitting inside current next. And that means my current is now pointing at AAA. I'll go back and I'll check the loop again. So my current is not equal to null. That is true. I've got a node there. And I'm going to check that my current data is not equal to value. If I go into the current data, it's 42. And when I check, is 42 equal to 42? Well, it is equal to that, which means that I exit out of this loop. And I'm going to check again, have I gone past the end of the list? So if current is not equal to null, which it's not, so I'm good to go, I'm going to check whether I'm deleting at the head of the list. Previous is equal to null? Nope, previous has a node, which means that I'm going to skip this if statement and go to the else. Now my else is saying take the current next. So inside my current next is the address BBB, and place it into previous next. Previous is over here. So this previous is now going to be, instead of that, it's going to be pointing to BBB, which means that I've just created this connection over here. I'm now pointing from this node to this node. This current node is now kind of, it's just hanging out. So I've done that, and I'm going to go over here and I'm going to free the current. So my current node is now going to get deleted, and I'm good to go, so my list is now going to be 11, 13, and everything is hunky-dory. Okay, fantastic. And then you should try that again for like a tail deletion, and you should try it for run through the code yourself, right? And make sure that it's all working. So now let's have a look at what is happening with our memory leak. Okay, and nope, this is all incorrect. Not again, but I'm back. I can see, I'm back. I should be back. I can see my SSH is back, so I'm back. We back. Don't worry. I hope you haven't lost too much of what I said. No, we're back. We're back. What a disaster. Okay, I'm going to compile with the leak checks. I'm going to compile my .c files, never doing this lecture from home again. It is happening from, I was just saying, it's too bad if the person next door to me is unhappy with my lecture and listening to me. They're going to have to listen to me. Let's leak check. And then we're going to name it something. What have I done now? Okay. Who's noticed what I've done? There we go. Okay, so all good here. And now let's run this. And I've got this error, okay, which leak check will give you if you haven't deleted all the nodes or if you have some memory. So if you remember, what happens is I've got this 42 and 13, and my list used to be 11, 42, 13, and I deleted 11, but I have malloc memory for each and every node, okay? So I've malloc memory for each and every node, which means that I have not freed upon, I've not given back the memory that I've malloc for node 42 or for node 13. And you're going to see this in assignment 2. This is one of the most common things. People start to lose the plot because they're like, I don't know what I haven't deleted. So you need to make sure that you delete every single node, and then you will not have a memory leak. So someone has already said that before we went on the break. But if I run this delete all nodes, right, at the end of my main, what will happen is all of my nodes will be deleted, okay? And I'm not going to have a memory leak. So let's try it. We're going to run this, compile it, and then we're going to run it, and we're going to see if we get the error again. And we no longer get the error because now we've deleted every single node, right? So there is every piece of memory that we have malloced, we got it, we've freed it, okay? So leak check is a DCC thing. And basically there is a whole bunch of tools that you will learn about the further on you go. And what DCC does is it allows you to use those more advanced tools, and it abstracts them away from you so that you can just type in leak check and check it without actually having to know how to use these more advanced tools. Okay, so use DCC especially at this foundation stage because it's really it's going to help you, right? Because it's going to allow you to advance further. You're going to stop using DCC. You're just going to use standard compilers. And then you're just going to, potentially hate your life at some point. Okay. No, we can't be gone again. No. We're back. You know what? The Australian internet, anytime you go anywhere else in the world, you're like, this internet is so fast. This internet's so amazing. But not in Australia. In Australia, it's just, ugh. And it's because I have good internet, but not from my house to the node where good internet starts. So that little section between my very old house and where the node is a disaster. Okay, you know what? I'm cooked. So is my internet. Do give me some feedback, but please don't complain about my internet. I will go back to the university next week. It's I'm sorry that not ideal. So hopefully it will be fixed. Thank you so much for joining today, and thank you so much for listening and participating and engaging. It's really so nice when the chat is going and when people are talking. It's much easier to kind of keep everything going. I hope that deleting nodes is okay and has gone okay. Next week, I plan to talk about the exam, and I plan to do a whole bunch of linked list questions. I was going to do a little bit of like assignment stage 1 kind of work. So Let me know if you want me to do that, and then we can, and then we can work from there if you still want me to do that. All right. I hope you have a great rest of the week, and I'll see you guys next week on Monday. Thanks, everyone. Bye. Oh, I didn't mean for it to give fireworks. That was an accident.